Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 25 to 29 of the Algebra 1 Common Core Regents exam for June 2015. All right, let's take a look at problem 25. It reads, graph the function y equals the absolute value of x minus 3 on the set of axes below. All right, so to generate this graph, we can make use of our knowledge of the absolute value function, or we can use a table of values. In this problem, I'm going to be using a table of values, okay? So let's go ahead and set up our table of values, our input-output table. So we have, let's go ahead and do that. So we have our x and then our y. So y is equal to the absolute value of x minus 3. All right, so the question is, where do we start our input and output table from? In this problem, by taking a close look at the function that we're dealing with, you will be able to determine the best place to start your input-output tables from, okay? Now, if you take a look at this function, you have x minus 3. Okay, when a function is written in this form, in standard form, you can simply take the opposite of the number next to x, sorry, to determine where to start your, where to place your input-output tables around. Okay, so what is the opposite of negative 3? The opposite of negative 3 is positive 3. So that basically means you want to center your graph around 3. Okay, so we're going to put 3 in the center right here. The absolute value function is like a v, and the x-coordinate of the vertex can be found by using the steps we just did. Take the opposite of the number next to x in the absolute value bars, all right? Another way to do it is you see this quantity right here, x minus 3. Set that equal to 0, and then you solve for x by adding 3 to both sides, and then you have x equals 3, and that will be where the table should be centered around. So what does it mean by centering your table around 3? Well, from 3, you're going to go 2, 4, and then 1, 5. Okay? So as we fill out this table, you're going to see something happen, something pretty cool. Now let's start from the center, which is 3. We're going to plug it into this function. So y is going to be the absolute value of 3 minus 3, which is equal to the absolute value of 0, which is equal to 0. Okay? Now let's go on to 2. If you plug in 2 into this function, you have the absolute value of 2 minus 3. 2 minus 3 is negative 1. The absolute value of negative 1 is positive 1. Now watch closely what happens when I plug 4 into this function. You have the absolute value of 4 minus 3, which equals the absolute value of 1. 4 minus 3 is 1, which is equal to 1. Do you see a pattern here? Certainly, you see you have 1 and 1. These two are the same. Now, what do you think is going to happen when I plug in 1 and 5 into this function? Well, let's go ahead and try it out. 5 minus 3, absolute value, equals absolute value of 2, which is equal to 2. Now, can you guess what this output is going to be? It's going to be 2 also, because this is a symmetric function. Okay, it's symmetric along x equals 3. All right, so let's go ahead and verify that. So we have 1 minus 3 as absolute value of negative 2, which is 2. Perfect. The nice thing about setting your table around the vertex is that you can check your work. You can see the symmetry happening if you have an even function. Okay, so all we're going to simply do now is just graph these points. So when x is 3, y is 0, so 1, 2, 3. So when x is 3, y is 0. Our graph should look like a V, okay? That's what absolute value functions look like. Now, when x is 4, y is 1, 4, 1. And when x is 2, y is 1 also. When x is 5, y is 2. And when x is 1, y is 2 also. Okay? So there goes your absolute value function. 1, 2, 3, 4, 5. And then this is 0, of course. And this is 1 on the y and 2. So we can go, we don't need to put in too many points. These points are sufficient to generate our graph. So you just draw a perfect line following that pattern right there. And then the other one right there. Okay, this is a translation of the parent absolute value function. That's what yields this function right here. So this function is y equals the absolute value of x minus 3. Okay? All right, let's take a look at the B part. It says, explain how the graph of y equals the absolute value of x minus 3 has changed from the related graph y equals the absolute value of x. Now, this function right here, y equals the absolute value of x, this is the parent trig function, okay? Do you know what this function looks like? What is this function centered around? The parent absolute value function y equals absolute value of x is centered around 0. So let's go ahead and sketch what that is. So the absolute value function, let me draw it in dotted line, y equals absolute value of x is something like this. Okay? Something like that. Now the question is, what do you do to this broken function right here, y equals the absolute value of x? What do you do to this function to get to this function? You shift. You shift how many units in what direction? You shift 1, 2, 3, 3 units to the right. That's all you have to do, 3 units to the right. And that gives you this function right here. See this minus 3? That is a giveaway. This minus 3 basically means you shift 3 units to the right. It's kind of opposite, okay? So explain how the graph of y equals absolute value of x minus 3 has changed from the related graph y equals absolute value of x. So you just simply write y is equal to x, absolute value of x minus 3, results from shifting the related graph y equals the absolute value of x 3 units to the right, and that's good enough. Okay, all right, let's take a look at number 26. It reads, Alex is selling tickets to a school play. An adult ticket costs $6.50 and a student ticket costs $4. Alex sells X adult tickets and 12 student tickets. Write a function f of x to represent how much money Alex collected from selling tickets. Okay, so let's go ahead and write down some formulas that will guide the generation of our function. So the main formula here is the total cost formula. All right, so the formula, let's write it down. For total cost is basically, or price is basically the unit price multiplied by the quantity. All right, so we're going to apply the formula to the two situations here. What are the two situations? Adult ticket sales and student ticket sales. Okay, so let's look at that. So let's start with adult. All right, okay, so for adult, the total cost for adults is going to be the unit cost for adults, for one adult ticket, times the number of adults, okay, or number of adult tickets sold. So unit cost of adults plus number of adult tickets sold. Okay, all right, so now let's take a look at this situation. Let's apply this formula to this situation. Total cost per adult is going to be unit cost. What is a unit cost per adult? How much does each ticket cost? An adult ticket costs $6.50, so 6.5. How many adult tickets were sold in all? Alex sells X adult tickets, so 6.5 times X. 6.5 times X is equal to 6.5X. This is the total cost for adults. All right, now let's move, shift gears and take a look at students. For the student scenario, total cost for students, what can you see what the formula is using this format up here? It is a unit cost for students, okay, unit cost per student's ticket times the number of student tickets sold. Student tickets sold. Now, what is the unit cost for student tickets? Let's go back to the problem. A student ticket costs $4. So that's the unit cost for student tickets, $4 each. Okay, so unit cost for student tickets is $4 times how many student tickets were sold? A total of 12 student tickets were sold. Okay, all right, so 4 times 12, that's going to give us 48. All right, now let's take a look at the total cost as a function of x. Okay, so the total cost of everything combined is simply, let's write it down, f of x equals total adult cost, adult ticket cost, plus what? Plus the total student ticket cost. Okay, so you're going to add both of them together. So what was the expression for total adult ticket cost? Remember, it was 6.5x. So we have f of x equals 6.5x. Now, what is the total student ticket cost? 48, or 4 times 8, so 48. And there goes your final answer for the total amount of dollars collected by Alex. All right, let's take a look at problem 27. It reads, John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. The total amount of money Sarah will save is given by the function g of x equals x squared plus 46. After how many weeks x will they have the same amount of money saved? Explain how you arrive at your answer. Okay, so the goal here is they're going to have the same amount of money. So they have the same amount of money when these two functions are equal. Okay, so they have the same amount of money. They have the same amount of money saved when what happens? When the total saved by John is equal to what? Is equal to the total saved by Sarah. Okay, so what function represents the total saved by John? F of x. So basically, when f of x equals the function that represents the total saved by Sarah, which is g of x. So this is what we're going to do. We're going to solve the equation f of x equals g of x for x. What is f of x? F of x is 60 plus 5x. What is g of x? G of x is x squared plus 46. So this problem is actually having us solve this equation right here. Now, if you notice, there is a square that's the highest degree. So this is a quadratic. How do you solve quadratics? You can solve it by completing the square, factoring, or using the quadratic formula. But what you want to do first is write it in standard form. Set it equal to 0 with the degrees in descending order. Okay? Since the square is on the right side, I might as well move everything to the right side. So subtract 60 and subtract 5x from both sides. What does that yield? It gives us the quadratic in standard form x squared minus 5x plus 46 minus 60 is negative 14 equals 0. Now let's try and see if we can solve this resulting quadratic by factoring. If not, we'll simply use a quadratic formula. Now let's think about two numbers and multiply to give us AC, negative 14, and add to give us B, negative 5. So think about the products of 14, or we can use 7 and 2. Now how do we fix the sign so that it works out here? Negative 7 plus 2 is 5. Good. Negative 7 times 2 is negative 14. Perfect. So this factors into x minus 7 times x plus 2 equals 0. Now, to finish it off, we'll use the zero product property. X minus 7 equals 0, and x plus 2 equals 0. You set both factors to 0. Now let's get x by itself here. You add 7 to both sides. You have x equals 7. And then on this side right here, you subtract 2 from both sides, and x equals 2. So our answers are 7 weeks and negative 2 weeks. Okay? Which answer makes no sense? Is it possible to have negative weeks? Makes no sense, right? Since we're talking about weeks, weeks can only be positive, so this is the answer. All right, this cannot be an answer because weeks cannot be negative. It's outside the domain of time. Weeks can not be negative. So let's write down our final answer, contextualize the result. They will have the same. They will have the same amount of money saved in 7 weeks. Okay, so that's that. Now, the second part, which is really important, if you want to get full credit, you have to explain how you arrived at your answer. Okay, so let's go ahead and explain how we came up with our answer. Okay, so first of all, to arrive at the quadratic equation, we set both functions equal to 0 because that means they have the same amount. Okay, so set both functions equal to each other, not to 0, sorry. Set both functions equal to each other since we are looking for the x value that yields the same amount. Okay, there are different ways you can explain yourself. That yields the same amount. Okay, and then after doing that, you place your resulting quadratic in standard form and solve by factoring. Okay? Is that all there is? No, remember our last step, we eliminated a solution that was not part of the domain. So we have to include that in our explanation because that is important too. Okay? Since weeks can only be positive, we eliminated the negative result and ended up with what? And ended up with 7. Okay, so this is just an explanation of how you arrived at your answer. All you're doing here is looking at your result, your work, translating it from math form into words. So just write a nice little explanation just to show your teacher that you understand what you're doing. Okay. All right, let's take a look at problem 28. It reads, if the difference 3x squared minus 2x plus 5 minus x squared plus 3x minus 2 is multiplied by 1/2 x squared, what is the result written in standard form? So this problem is assessing your ability to carry out operations on functions, namely finding the difference and then applying the properties of exponents. So what we're going to do first is find the difference. Okay, so we have 3x squared minus 2x plus 5 minus x squared plus 3x minus 2. Okay, so let's go ahead and rewrite this in vertical orientation so we can easily align our terms and subtract accurately. So just copy the first one down, 3x squared minus 2x plus 5. Now what you're going to do is you're going to distribute this minus to all 3 terms in this polynomial expression right here. Okay, what happens when you distribute negative to terms? It simply inverts the sign of every single term. So you're going to have negative x squared minus 3x minus times minus plus 2. Okay, what do you do now? We just combine it downwards. That's the beauty of writing it vertically because you can line up like terms and then just combine with ease. Okay, so we have 5 plus 2 is 7, minus 2x minus 3x, the signs are the same, so you add and keep the sign, minus 5x, and then this one you subtract, and you have 2x squared. Is this our final answer? Absolutely not. We're just done with the first part, which is finding the difference. We're now supposed to multiply it by 1/2 x squared. Okay, so we're going to take this answer and multiply it by 1/2 x squared. So to do that, we simply have to distribute 1/2 x squared as a whole to all 3 terms in the parentheses. Okay, remember your rule of exponent. Let me just write that on the side. Recall, when you multiply exponents of the same base, let's say x to the a times x to the b, what do you do with the powers? You add, right? X to the a plus b. You don't multiply, you add. Keep that in mind. All right, so if we carry out the distribution, we're going to have 1/2 x squared times 2x squared minus 1/2 x squared times 5x plus 1/2 x squared times 7. Now let's go ahead and simplify this. On this side right here, the first term, 2 goes into itself once, 2 goes here once. What is x squared times x squared? You add the powers, okay? X squared times x squared is x to the 2 plus 2, which is 4, minus 5. Now, how do you do 1/2 times 5? That's kind of complicated because 2 doesn't go into 5. Well, you express 5 as a fraction and you multiply across. 1 times 5, 5. 2 times 1, 2. Now, what is x squared times x to the first power? Remember the rule, you add the exponents, so you have x to the 2 plus 1, which is 3, plus 1/2 times 7. Remember, just express 7 as a fraction and multiply across horizontally. 1 times 7 is 7. 2 times 1 on the bottom is 2x squared. So there goes your answer, x to the fourth minus 5 over 2x to the third plus 7 over 2x squared. So that's that. All right, let's take a look at number 29, the last one in this review installment. It reads, Dylan invested $600 in a savings account at 1.6% annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. Find to the nearest cent the balance in the account after 2 years. So this problem involves knowing what your exponential growth rate function is, the formula, and using it to compute the amount of money you can get after 2 years. Okay, so your exponential function for discrete growth is a, let's call this, write it as a formula. So the formula is as follows. This formula, unfortunately, is not provided in your reference sheet. The one that's provided there is exponential growth and decay, not discrete. So you have to know this, have this memorized before you take your Regents exam, okay? So this formula, note, is for the interest that's compounded annually. If it's compounded n times in a month, in a year, sorry, then you have a different formula for that, but we're just going to focus on this. That one is a little bit more complicated. So this is a formula right here. Now, you don't just need to know the formula, you have to understand what each variable means. Okay, or else the formula is useless. So let's see what each variable means. So A is the final amount. Okay, in this problem, that's what we're looking for. How much did you have at the end of the period? P is what? P is your initial amount of principal. How much did you start with? That's what P is. R. Now, this is where it gets really tricky. R is for growth, your growth rate in decimal form. Okay? If you forget to put your answer in decimal form, you get the answer wrong. So it's your growth rate in decimal form. Notice, is this in decimal form? The answer is no. This is in percent. So when we're using this formula, we have to convert this percent to decimal. Last but not the least, T is the time, in this case in years. Okay, now we're going to apply this formula to the situation that we have right here. Okay, so let's start with A. What is A? What is the final amount? What is the amount that Dylan had after 2 years? Question mark. That's what we're looking for. Okay, what is the initial amount P? He started with 600. What is the growth rate? The growth rate is 1.6%. Is this good enough? Absolutely not. We have to convert this percent to decimal. To do that, you divide by 100, or you move the decimal point forward by the number of zeros in 100, which is 2. Okay, so move it forward 1, 2. Move it forward twice. Insert a 0 and a 0 there. So 1.6% is equal to 0.0. Oh, actually, I moved it. Let me do that movement again. So I think I didn't write it properly. So we have 1.6%. So we're going to move it twice. 1, 2. Okay, that's more like it. So we just have 1 0. Perfect. So 1.6% in decimal form is 0.016. Okay? And then T, how long, how much time did he have the money invested for? 2 years. So we have everything we need to compute the final amount. So we just set up the equation A equals P, which is 600, times 1 plus 0.016 raised to the t power, which is 2. Okay, so to generate the final result, we have to be able to enter this correctly in our calculators. Okay. Okay, so let's go ahead and do that. So we have 600 parentheses 1 plus 0.016, 16%. To raise it to the second power, you can just use square or carry 2. Okay, so I'll just use square here. That's our answer. We asked to round to the nearest cent. Okay, so 619.3536. Let's go ahead and write that down. So A is equal to 619.3536. Now to the nearest cent, A is equal to 619.35 to the nearest cent. All right, to the nearest cent. So what does this answer mean? Let's contextualize our results. Within the context of the problem, Dylan has, let me see, what did the question ask? So we can say Dylan will have, since we're talking about the future, so Dylan will have a balance of what? $619.35 after 2 years. So do you see how much interest he earned? He earned $19.35. Okay, so that's how much money he has. Okay. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about this tutorial or any questions on your Algebra 1 Common Core upcoming Regents exam, just place your question in the comment section below, and we'll be glad to address it as soon as possible. Don't forget to sharpen your skills by taking our interactive practice test here. More clips can be found on mathgotserved.com. Thanks again for watching, and have a great day.